Hi everybody, welcome. Glad to have you here. I'm Robert Wolfert and this is episode number 14 of Random Linux Tools Explained. And if you're here for the first time, then this is all about Linux command line tools you can use for your day-to-day work. And to make this type of tutorial a little bit more interesting for you, there is a small challenge added for me, and the challenge is that I'm not prepared at all. Just me and the terminal and perhaps a whiteboard, and I will get a randomly chosen tool, and then I will do my best to explain this tool for you, how or what this tool can be used for, how you can use this tool at best, which command line options in combinations with different tools, and if there are some things worth mentioning around or beside this tool. Okay, so let's start directly with sharing my screen. Here we are, and if you're interested, stay tuned while we choose a random tool. We have the random tools here from the shell toolbox, and I have a script shell choose tool.sh, and this script chooses one single tool randomly from this given tools there. Okay, so let's have a look what the tool of today is, and the winner is lsusb. Okay, for the ones who join in a little bit later, we are talking now about lsusb. Okay, so lsusb, what can this tool be used for? Well, let's start this tool, lsusb. And as you see, lsusb shows me nothing here. And that's just because lsusb is a tool that lists all USB devices on your system. And I'm here connected to a remote virtual machine, on AWS, and therefore there aren't any USB devices connected. And let's try to get a console from a system perhaps with USB devices connected. Let's try to start a virtual machine. And there you could see a little bit output from lsusb here. A Linux container is getting started here. It's German, the output here. Okay, let's make it a little bit taller, bigger, the size of the font, and let's start here, lsusb. And lsusb here gives us some information. We have two USB buses here on the system, two USB buses. We have a USB 2.0 root hub and a USB 3.0 root hub there. If we had connected, or if I had connected additional USB devices to this system, we would see these USB devices here. If you call lsusb and you want to know something more about the devices you see there, you can just use the verbose mode by adding the -v command line switch. lsusb -v gives you some more information about the devices you see here. You see the manufacturer, for instance, you see the type of the USB device, if it is a USB keyboard, a USB mouse, a sound device, network device, and so on. So these are the information you get with the lsusb tool. There are some other tools from this family of tools, there is a whole family of these tools for determining the hardware devices on your system. The tool I use the most is the tool lspci. lspci is a tool that lists you all the PCI devices on a system. Yeah? And typically, or most of the devices your system has built in are PCI devices. Yeah? And the externally attached devices are typically USB devices, and the built-in devices are typically PCI devices. So let's have a look if this virtual machine here gives me some information about built-in PCI devices. And yes, there are some. Yeah? We have, for instance, an VGA controller, a graphics controller here. We have an Ethernet controller here, for instance. Yeah? These are the information you will get with lspci. Yeah? If you are asking yourself, has this system an Ethernet port, a different Ethernet port, is there a SCSI controller built in, and so on, yeah, simply use the lspci tool for this. If you want to get more information about these PCI tools or PCI devices, just add here again the -v command line switch for the verbose mode, and then you will see a little bit more information about all these devices. For instance, I have an Ethernet controller here. This is an AWS virtual machine, an EC2 instance, yeah, with an elastic network adapter, and there is a kernel driver available. This is the kernel driver available, the ENA interface or driver, and this is the kernel driver that is currently loaded for this device. Yeah, if you have a look on different devices, you can often see devices with multiple available kernel modules, multiple available or possible loadable device drivers, and kernel drivers in use is exactly one single driver. Yesterday we talked about the lsmod tool and the mod probe tool, for instance. Yeah. And if I call lsmod here on the system, I will see that this module ENA is loaded. Let's have a look, lsmod, and let's grab the output for the driver ENA, and you see this is the loaded module here. Yeah, so we have lsusb for the USB devices, we have lspci for the PCI devices, and on some distributions there is are two additional tools installed sometimes from this family, and these tools are first lscpu. Please give me all the CPUs on your system, and you see here the tool lscpu is installed. Yeah, you see the CPU, you see the number of CPUs, you see the vendor, you see the megahertz with these CPUs are currently running, and so on and so on. These are the information here are taken from the proc directory. Proc CPU info gives you the raw information about the CPU or the CPUs on the system, and alias CPU builds you perhaps better readable, a more compact output from all this information you have there. Yeah. Okay, so we have again lsusb, we have lspci, we have lscpu, and then there is a fourth tool, I think, installed here on the system, and this tool is lscsi. lscsi for listing all SCSI devices. Yeah. So if you have a SCSI disk on the system, if you have a SCSI DVD ROM drive on your system, yeah, then you will see these devices via lsSCSI. Yeah. This tool here is not installed. Let's install it. Yeah. Sudo apt install lsSCSI, and let's have a look. lsSCSI gives you all the information about the SCSI devices. Let's call this via sudo. Nothing happens. Let's go to the other virtual machine here, lsSCSI, as sudo apt get install lsSCSI. Let's see if we will get some output here. lsSCSI. Okay, nothing happens. No SCSI devices here. Yeah, and then the last one, lsblk, for list all available block devices. Yeah, if you want to see your available block devices, try to use lsblk. Yeah, lsblk is also only a tool that collects information from different sources on the system and then builds a table for you, yeah, for convenient reading. The information can be found again within the proc file system. Yeah, within proc you have devices file. Yeah, within this devices file you see all your devices. Then you have tools like fdisk-l, for instance, for listing all available partitions and so on. Yeah, and the tool lsblk collects all these data together, yeah, and builds a nice table for you. Yeah, so these are the tools from this ls family: lsusb, lspci. Then we have the lscpu on the system. We have lsSCSI, SCSI not installed here on the system, or it wasn't installed here on the system, and this didn't give me any output. And then we have the last one here, lsblk. Yeah, so this is the family of the ls tools for hardware devices on your system. Yeah, keep in mind all these tools can be called with the additional command line switch -v for verbose output. Yeah, to get some more information about the things you see there. Yeah. Okay, so these are the tools correlated to lsusb. Okay. Yeah, all the information the tools get are taken typically from the proc directory, and they are typically taken from the dev directory, dev, and they are typically taken from the sys directory. Yeah, these are pseudo file systems there, and these file systems gives you some information about your system. Yeah, within proc, this is a kernel interface. You can read directly to the kernel. The dev directory gives you all the device files available currently on your system for connecting, yeah, your user space with the devices, with the hardware devices. And we have the sys directory here in place that gives you a view to all your devices on the system from different viewing angles. Yeah. Okay, so this was lsusb. Yeah, we have plenty of time left. We have time left So let's take another tool. Let's go back to tools. If you have any questions about the tools here, about something else, yeah, leave the questions or your comments below the video in the comments. Yeah. So let's get a different tool, another tool. Okay, let's start. Choose tool.sh for a second time. Make some new tools, and the winner now this time is WC. Okay, I talked about WC within, I think, episode number 2 or 3. I don't know exactly, but if you didn't follow this episode, yeah, let me explain what a WC tool can be used for. WC is a tool. First, let's update the banner here. We are now talking about WC. Okay, WC is a tool for counting. Yeah, if you want to count something, then simply use the tool WC. WC can count, for instance, can count lines. Echo, hello, hello world. Talking and typing at the same time, not always this easy. Echo hello world, pipe WC. You see, WC takes the input or takes data stream as an input, and then it counts. We have one line, we have 2 words, one line, 2 words, and we have 12 characters here. If you call WC without any parameter, yeah, then WC reads from the input data stream. Yeah. Hello WC, show what you can do. And WC reads everything in, and if WC sees that the input has ended, it simply counts the whole data stream. And how can I end the data stream here? If I hit Control-C, yeah, I will terminate WC command. Yeah, that is not the best way, so WC cannot count. If I hit Control-D, yeah, Control and D together, then I send an end of file marker to WC, and WC sees, okay, nothing more to come on the input data stream, so let's count this. We have now here 3 lines, we have 9 words, 1, 2, 3, 4, 5, 6, 7, 8, 9 words, and we have 37 characters here. Yeah, I don't want to count characters. WC can count from the input data stream, and WC can count from a file. Yeah, if you want to see how much is within a file, how many lines, how many words, how much data is within a file, yeah, then you can simply give WC the file name as a parameter. For instance, let's see what's within etc passwd. Yeah, we have 35 lines here, for instance. If we want to count only the lines, we can do it this way. WC-L only counts the lines. Yeah, and this is really useful if you wanna count something from the output of a different command. Yeah, let's say I want to see all the shells running here on the system. Yeah, let's say I list all processes with psax, and then I grab, for instance, for the bash, I filter for bash, and now I want to count how many lines are within the output, how many processes are running, yeah, with bash in the name, and I can simply use WC for counting the lines. Yeah, so there are three processes here. Or let's say I want to count how many files are within my current directory. How many files are there? Yeah, simply let's call ls pipe wc-l. And you see we have 7 files. Really 7 files? 1, 2, 3, 4, 5, 6, 7. Yeah, really, 7 files. Robert, didn't we count the lines here? And ls just prints out one single line. Why the hell is the wc command here telling me that we have 7 lines here? Yeah, that's just because the ls command here sees that there isn't a terminal within the out or connected to the output data stream. Yeah, typically the ls command will give you a listing, yeah, nice color, so that you see this is these are directories, and this is an image file, and this is a script, for instance, and an executable file. Yeah, but if the the ls command sees that the output isn't connected to a terminal, then the ls command will print out every file name line by line. How can we prove this? We can prove this simply by choosing a different tool or using a different tool, the tool cat here. The tool cat is a tool that simply reads from its input data stream. It reads from the input data stream and prints everything out to the output data stream. And I use this tool here now only for showing you that the ls command, yeah, generates an output with all the file names line-wise if the output data stream isn't connected to a controllable terminal. Yeah, and this is the information you get from cat, and this is the same information the wc command here sees. So the wc command simply counts the lines. Yeah, 1, 2, 3, 4, 5, 6, 7 lines here. Yeah, don't make the mistake and call ls-l for forcing a line-wise output. If you do it this way, then you will see a number more, one line more than without the -l command line switch. That's just because the ls command simply prints out a line more, yeah, a status line more if you call it with ls-l, yeah, with the -l command line switch. So if you want to call, if you want to count the files within a directory, simply use ls, yeah, wc-l. How many files are within the etc directory? Yeah, let's pipe the ls output to wc-l, and you see 186 files here directly within the etc directory. Yeah. Okay, so wc can count the input data stream or everything it sees within a file. Yeah, for instance, etc passvd, or for instance demolog, or for instance hello.sh. You can call wc with multiple files if you want to. Yeah, and then wc shows you the information. etc passvd has 35 lines and demolog has 8,751 lines, and so on and so on. Yeah. Okay, wc for counting lines, wc for counting lines, only the lines, for counting only the characters, for counting only the words here. Yeah. So if you want to count something, use the tool wc. This is the tool for counting something at the console. Yeah. No matter if that something comes from the output of a command, if that something comes from a file. Yeah. Okay. So let's take a third tool today, I would say. Yeah. Back to the tools directory, and let's call the choose tool.sh again. And the third tool for today is, the winner is wc, not again wc. We have talked about wc already, and the winner is which. Okay. And let's update the banner here. We are talking now about the tool which. Which is a tool that gives you the information where an executable file is located. If you try to interpret a command line like the shell would do, for instance, echo hello world, yeah, then you would simply split the line into words, and the first part, the first word of the line is your command, and this is the command you want to run. And there are 4 types of commands on a system. And the first type is a so-called shell built-in. Echo, for instance, is a shell built-in. This isn't executable somewhere, or this doesn't have to be an executable somewhere on the system, but the shell exactly knows what to do if it sees the echo command. This is a shell built-in. If you want to see this, you can simply use the type command. Yeah, type and a command as a parameter gives you the information if this tool is a shell built-in. And you see echo is a shell built-in, and as is cd, for instance, and as is export, for instance. So these are some example tools, yeah, that are shell built-in. So the shell exactly knows what to do. Then the second type is an alias. You can define, if you want to, a new shell built-in. If you want, yeah. Let's say I want to define a tool hello, and this tool hello, if I call this tool, then this tool or this command line should be executed echo hello world. So now I have defined an alias. I can use this alias just like any other command, and this is an alias. Yeah? Type shows you that hello is an alias, and there are other aliases predefined on many systems. For instance, the alias ll that simply calls ls-al uppercase f. Yeah? So this is the second type of command, aliases. The third type of command is a function, and a function is an alias on steroids, I would say. An alias on steroids. An alias that can contain multiple command lines, an alias that can contain loops and expressions and can take arguments and so on. Let's have a look if there is a function available for showing quote should be defined. Yes, and it is defined. Quote is a function. Yeah. Okay. If you are scripting on a system, if you write shell scripts, yeah, then you will typically use functions to simplify your code. Yeah. But for now, take a function as an alias on steroids. Yeah. So you have shell built-ins, you have aliases, you have functions, and then if the command on the command line is neither an alias, not a shell built-in, and also not a function, then it has to be an executable file somewhere. Yeah. And somewhere on the system means that the shell has to search for an executable file. And to speed this up and to make it more secure, the shell only searches on predefined directories. The shell searches only in predefined directories for executable files. So if, for instance, I call ls/home, then the shell sees ls, and ls needs to be or has to be an executable file, is an executable file, then the shell looks into home robot bin. Is there an executable file called ls? Yes? Okay, let's run it. No? Okay, let's go into home robot local bin. Executable file there with the name ls? No? Okay, let's go further, and so on and so on. And then the shell somewhere or someone comes to the bin directory, and within the bin directory there is an executable file, yeah, called ls, and this then will be started. Yeah. And if you want to do the search here, you can simply use the which command for this. Yeah. You can simply ask the which command which ls will be executed if I call ls simply as a command? And the answer is bin ls will be executed. Let's copy. I have an example script here within the current directory. Let's create this directory here. Yeah, I'm currently within home robot. Let's create the directory bin here, and let's copy this example script hello.sh to the bin directory, and let's choose the name ls for the new file for the copy. So now we have within bin an executable file called ls. And now let's ask the which command, which is the ls that will be executed if I call the command ls, then which says me that home robot bin ls is the executable to run. Let's prove this. Let's try to list the content of the home directory. It works. Why does it work? I have overridden the ls command. It works just because the shell has cached where the executable file was located. If I type ls, ls is an alias to, okay, and but the shell has cached where the binary was found. Let's try this with a different bash. Let's call it bash, and now let's call ls. This is a fresh bash, a fresh shell without any cache in the background, and now you see the ls command gives me just a hello world, and just because this bin ls tool here, the script just prints out hello world. Okay, so ls is now an executable file in a path before the file where the original ls command executable file is located. Okay. If you want to call the original ls command here, you can simply tell the shell which command you want to start. By simply giving the shell, or give the shell the path to the tool. And now you see bin ls lists you your content. Only if the shell has to search by itself for an executable file with a given name, then the shell searches every directory within the search path, within the variable path, $path. And if you want to ask the shell which is the executable file that would be executed, simply call a which tool, which passvd, which less, and so on. For all executable files, the which command can be used. Okay. And if you want to know more about such tools like the ones we talked about here, there are much more. Have a look at the Shell Toolbox at shelltoolbox.com. And if you are interested, tune in the next time I do a streaming like this. But for now, let's end the streaming. I really appreciate that you were here. See you next time. Bye.